So for everyone who's attending, welcome to the Strumenta community panel session. I will be the moderator for this session, but my job is just to make sure that we somehow or try to respect the time slots that we have. In this session, we'll have three talks. The LionWeb initiative by Nico Stotz and Jos Warmer. The Chisel method for writing parsers by Federico Tomasetti, and implementing symbol resolution in Starlazu by Lorenzo Addazzi. Each talk has more or less 40 minutes of time, which will be roughly divided as half an hour for the talk and 10 minutes for the questions, more or less. And then, of course, if the speaker wants to leave more time for questions, they are free to do so. For questions, well, I can't see that in my user interface, but attendees should have in the bottom part of the screen, they should have a button for making questions, and I will check the panel from time to time and write down the questions, so I will be able to make them to the speakers. And I think maybe it's also possible to write them in the chat. I don't know. I'm not sure about that. Anyway, enough talking, and let me introduce the first two speakers, Nico Stotz and Jos Warmer. Nico is a long-time expert in language engineering. He's worked on designing and implementing DSLs, first based on the EMF technologies, and now mostly based on MPS. And he's currently continuing his work on language engineering at FIRE, while before he was working at Canon. Jos Warmer, the other speaker, has been doing modeling, meta-modeling, and domain-specific languages for many years. He started with research on SGML that later evolved into XML. And from there, he went through the use of many different technologies like Xtext, Graffiti, Microsoft DSL tools, MPS, and even plain old Java and TypeScript. In recent years, among other things, he's worked for Mendix under his own company, Open Modeling. His most recent work includes the web-based projectional editor Projectit and the web-based language workbench Freon. So now I'll shut up and let Nico and Jos speak about the LionWeb initiative. Thanks.
Hey, thank you, Alessio. Presentation from Nico and me will be divided in two parts. I will do the first part, which is a few sheets with an overview of what LionWeb is and what we're trying to achieve. And then Nico will give a demo of all the software we wrote that actually shows how it works. So stay here because the second part is probably more interesting than the first part, but listening to the first part helps you to understand it. Next sheet, please. Okay, next sheet, overview. So what is our mission? Well, we have a wonderful sentence. We want to create an ecosystem of language-oriented modeling tools and components that can interoperate with each other. And the idea is that it would help adoption of language engineering, more things to reuse, more things you can put together instead of writing everything yourself. It will reduce vendor and technology and tool lock-in. And nice thing is, instead of building the base every time yourself, you can just use a generic base from existing components and do the fun innovation stuff on top of it. So hopefully we get a little lot more innovation as well. Next sheet, please. So why did we start? Well, the web part of LionWeb should be clear. There's a lot of desktop-based language workbenches, but everything needs to go to the web. That's simply what the world asks from us. Re-engineering the desktop things is hard, so we start from doing things on the web. The second point is a very important one. We have a very fragmented landscape. Once you start with one tool or one tool chain, then you're stuck with it. So if you start with NPS, it's very hard to use interesting components from EMF or eCore. And if you see a nice thing from Strategia coming by, no way you can use it. You're always in one specific tool. And I see a lot of interesting components that I would like to use, and maybe that's going to change. And in general, our community is a relatively small one, and we think that the community can only grow if we can benefit from each other's work. Then with less work, we can do more, and it becomes more interesting. So LionWeb is a shorthand for language interfaces on the web, but you can also name it interoperability on the web or integration on the web. These are all things that we like to achieve. Next, please. So how do we do this? Well, we try to do the boring stuff so you can do the interesting stuff. And basically, we use a yo-yo approach from writing specifications and then actually implementing them in code. And then we see that the specification isn't as nice as we thought. And we go back and we rewrite partly, and we go up and down a few times until we have something that at both levels is understandable and usable. We follow the idea that everything is a model. Marcus Velter wrote a white paper about that several years ago. Still interesting to take a look at it. We'll see some of that later. And since we want everybody to use this and get their tools together, we have a very business-friendly open source license. Next sheet, please. So what are we working on? Well, last year we've been working on a meta model, the model with which you define languages, and a serialization format which is JSON-based, and that's basically describing the information and the structure of things that you can send between tools. This year we started on the build protocol, which is an API for a model repository. And it describes how you get and put models into the repository. And we got a bulk protocol, which is basically dealing with give me a subtree and I store a subtree. We have a delta protocol, which is about, okay, something changed and I want to subscribe to changes in a model. So you get more into a collaborative mode if you use that one. Those are the specifications we write, and we back them up by writing APIs for programming languages, Java, Kotlin, TypeScript, JavaScript. We've done several tool integrations just to see whether it actually works. And you're going to see, I think, all of them actually in the demo, MPS, Talazu, Freun, and eCore. And we started on a reference implementation for a model repository. So we actually know that the protocols we define are actually working and doable. Next sheet, please. What we're not doing, that's also important, we're not defining a language workbench. You can define a language workbench on top of this or communicate between them. We don't expect components using LionWeb to be plug and play. They can talk to each other, but you still have to think on what the meaning is of what you actually send to each other, and we don't care about deployment schemes. Next, please. That's what we don't do. Next. Okay, technical overview. Next, please. Okay, first part. We've drawn up a reference architecture. It's not like this thing is mandatory, but it's a very good description of how we view the world and how the things can work together. In the center, we have a model repository, which contains models. And we make a distinction between original models made by persons usually who sit at a monitor and type stuff or click stuff, and derived models, And derived models are completely derived from other models, so you can throw them away and recalculate them. So, for example, a type model for a language, which calculates all the types, is typically something we call a derived model. Next. Then we have clients. Well, these are two editors, could be visual, could be projectional, could be textual, and they will typically go to the repository, fetch a model or part of a model, edit it, and send it back. Next. And we see clients which are basic automated things, like the model checker. That's a processor that just takes a model from the repository, find all the problems or the issues with the model, and put back the issues as an issue model in the repository again. And we view that as a model as well, because it's connected to the original model on which the validation has been done. You can have importers that take something from the outside and change it into a LionWeb model and store it, or exporters or generators that generate code or documentation or whatever for models. Next, please. Oh, yeah, this is important. The thing we focus on in LionWeb is the connections between those tools. How you build those tools, we're not really diving into them. We're building a few of them, but that's not what we define. We're talking about how they connect with each other. Next. Okay, next. If we talk about protocols, what we're working on right now, we make a separation between a bulk protocol. For example, in number 5, the editor can just grab a model from the repository, edit the model, and then send the whole change model back. So that's what we call bulk, because you talk with whole trees and whole models. And for example, importers can also just take a whole model, change it into LionWeb and store it. Next. And usually if you derive something or export something, you also take just the whole thing and you export something completely. Next. The second type of protocol we call delta protocol, and delta protocol sends deltas, which means changes to a model, and it allows clients to subscribe to those changes. So for example, the model checker, number 1, might just do a check on the whole model, subscribe to changes to the model, and each time an editor changes a model or part of the model, it will just get a notification. It can see whether issues disappear or appear. And then, of course, the editor can subscribe to changes on the issue model and can see, oh, there is an error, and it might show it in the editor. Next. Okay, this is what we define as a meta-meta model. I can talk very long about it, but I won't even explain it. If you know the EMF meta-meta model or the NPS meta model or the Throne meta-meta model, they're all more or less the same. And we have mappings back and forth between all of them, so we know that this is kind of generic meta-meta model. Next. Standard library, we have a few things we predefine, so you can use them if you define languages. Yeah, next. Okay, showtime. Nico, it's yours.
Yeah, thank you. So I'll take over from here. Thanks, Joks. So I will show a small demo. And in this demo, I use this language. It's a very boring language, right? It's defining for a properties file, and we modeled it. And yeah, it's really nothing special. You have a properties file which contains properties, which contains values, which can be of different type, and these things are named. And when you work with these, as a language engineer with these with languages, the idea is we have this meta model in LionWeb format, and we can use them in all these different technologies. So we can use them in Kotlin, we can use them in MPS, in Fern, in eCore, and then do stuff with this. And also, this is the M2 level, the language level. And because we can use it all of there, we can also use the interchange the M1 level, so the instance level. And in our case today, we have define the languages in MPS and export them into all the other stuff. Yeah, so actually I will now show the language part. So you see MPS here. And here's the same language, right? What we just had. Yeah, if you ever saw MPS, it's exactly as you would expect. We have a concept, if it's an unnamed concept, which has some property children, and it's exactly the same. You might see some additional things here, which are called LionWeb. They make your life a bit nicer, but actually it works with any MPS language. So any MPS language can be used with LionWeb. And all the code we work with today is directly accessing loader. This one I want. It's directly accessing the information from MPS. So you see here we have this load instance, which gets this from some local port with some URL that nobody can read. And we do the same here with load language. And that's this URL, which I will not actually copy and go for my web browser. And there you see actually the JSON, the LionWeb JSON format. And yeah, it's pretty verbose, but you can actually, as always with JSON, if you know the structure, you can start to read it. So for example, here somewhere we find the node with LionWeb props, which is where is the concept? Here, classifier is a language, and it has a name. Here's the name, and it contains Boolean value and properties file and properties. So all the stuff we just also saw in the language. So the first thing we want to do is we want to generate the Kotlin classes from this. And yeah, in this demo, so the demo is available. We will show the URL later. It's on GitHub. So we have integrated everything in Gradle. And what this now did, we now have here, if I click the microscopic icon, we have the same thing represented in Kotlin, right? It's a very boring. So we made data classes and for each of them, and here the properties file, which contains the properties. And yeah, as you would expect, it's this whole, as we said, we want to do the boring stuff. You can do the interesting things. So now we have it in Kotlin, but actually we want to also show this in EMF. So then I need to have the properties EMF generator, this one, which fails. That's great. Okay, then clean. I tried this before, then it worked. Of course, looks better. So now what we got is here the ecore file of the properties. And there again, it is what you expect. It's a regular ecore file where we have these properties, and if we look into the thing here, we see it has a name, properties fall, and it's not an interface, and it contains properties. Again, if you know EMF, that's exactly as you would expect. And now we have the EMF file, but we also actually want the Java code out of this. So again, now we need properties EMF to find the generate xtext. That's the one, which actually does not generate xtext, but this is how you start the EMF generators. And then you get the Java files that you would expect. So here is the E package. That's the language representation. Here you have the properties file. which implements our everything we expect, contains the properties. EMF is, I guess, known to quite some people. So now we handled the language level. Let's have a look at the instance level. So I will briefly go back here. What we want to do is we have a properties file. Then we take the Kotlin code. This is actually Colasso, part of Starlasso. Parse this and create a model instance of it, which we then load in NPS. Then we will take Fern to edit this. Afterwards, we will use EMF to generate an HTML page. And then we will serialize it back using Colasso into a change properties file. Of course, this demo makes no real sense, but yeah, we want to show how all the technologies interact. So let's look at one of our properties files. Find it. This one, yeah, it's a boring properties file, as you would expect, which you now want to parse. So we need to find the right Gradle again. It's parser run. Yes, this one. It runs a bit, and then we get the JSON file, which looks very similar to the file before, but now actually we see that this contains here. We look at the classifier. This is a properties file which contains 3 children, which are the 3 properties we've just seen. And if we look back at our presentation, so we've done this and we've done this. Now we want to get it into MPS. So let's switch to MPS, where we have this import. We just point at the file we just created, say import. And actually, if we look in the messages view, it tells us that it converted 7 nodes. And if we look here, yay, we have 7 nodes. We have the model we've just seen. And now I actually will copy this into this other model, which makes my demo easier. The next thing, so we've done this one, right? We have it in NPS. Now we will use Fern to edit this one. So let's go to Fern, which we have here. We say, yes, we want to open this model. So we see it here, and then let's edit it. Hello from Strumenta. We can add a new property and have a name. And we make it a decimal property with 3 because that's a great value. Yeah, so here we have our model, and this is a bulk editor, as Jos described. So we actually loaded the complete model, edit it, and then save it again. So it's saved. It looks red, but it actually worked, and I can prove that because now the values we just changed are here in NPS. Okay, looking back at what we want to do. So we've done this one. Now we want to use EMF and more specifically extend to generate something. In this case, we generate a simple HTML file. So let's go back to Eclipse. And this is actually the reason why I show all of this stuff in Eclipse, because yeah, editing extend, you need Eclipse. So we look at our generator. Where is EMF generated? Properties, EMF. There's EMF generated. This one. So this is our generator. And yeah, so we first have to do a little bit to set up eCore. Then we have to do a little bit to set up LionWeb. And then we load the instance from MPS. This is this file that I showed before with this unreadable URL. Then we deserialize this stuff. We need to, and then we have it as LionWeb nodes. But then we want to convert it into EMF, right? So we need to set up the mapping, and then we need to do the conversion, and then we need to find our properties files, or our root node. And then we need to do some stuff so our generation works. And now we can here actually, so if we look at this properties file, and this is actually the EMF we generated before, right? So it's really integrated. And now let's look back here. Now we can use all the nice features of Extend, right? We have these nice template language where we have white space and gray space. So you already in the template see which parts will actually end up in your generated code and which not. And you see here, this can get actually quite sophisticated. And we can also use polymorphic dispatch. So if we here just say property, it does polymorphic dispatch on the actual type of the value at hand. So all the really nice features of Extend. So now let's run this. And that's generators EMF. Where is it? EMF generator. Yes, this one. Transfer a second. Okay, it's 1 second, but now it ran, and now we have our great HTML file with our very sophisticated new property. Actually, the demo also contains doing the same. If you look at this, we implemented the generator 4 times. We implemented it again in EMF without using the generated code, but then you can only use half of these nice features. So this looks not as nice, but yeah, it works. And it's also implemented again in Kotlin and in Kotlin Reflective, which actually looks pretty similar because, again, we have nice types. So this is different, and we can mix all of this pretty nicely. So looking back at our plan, what we want to do. So we have the EMF instance and created the HTML file. Now we want to get using the Kotlin code, Cola, so we want to get our properties file back. And of course, this is yet another call into Gradle. So find it here in history, blah, 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 blah. Ah, this one, this very long one. And you see here, it live downloads again the instance from MPS. That's why we have this unreadable URL in here. And then we should find here the property root file, which now contains our changed string and our great new property. Okay, so far the demo. Getting back to my slides here. Jos, do you want to do this?
Yeah, okay. Well, the team we have is not just Nico and me, but it's all the 10 people mentioned here from very different directions. We have grammar people, projectional people, language people, modeling, method modeling people in there. So we have quite a lot of different point of views, which is sometimes leads to very long discussions, but we always come to some kind of useful answer. If you want to work with us or join us, we have an email address. You can just ask questions there, but the easiest way is just go to our Slack, and there you can ask questions and get feedback, or even better, if you want to implement LionWeb, you can actually get a lot of help there on how to do it for your specific technology. And basically, we try to be as open as possible. So if in one way or another you want to join us, that would be great, because this is only going to work if enough people say, yes, we want this, we need this. Next slide. Is there another slide? Yes. Well, what are working protocols? Both bulk and then delta protocols. We expect that we have to refine the meta model, everything we have already, and we want to extend the reference implementations and examples such that it becomes easier to actually use all this. Okay, that's the end of the presentation. Thank you very much.
Sorry, my audio was disabled. Thank you, Nico and Jos, for your presentation. We're now open for questions. So if anybody has some questions about the talk, please write them in the questions panel. Don't be shy. In the meantime, Federico is asking if someone can copy the link to the Slack invite as a question, or you can also write it in the chat, and I will send it to all the participants. So we have a question already by Jürgen Muschal, who's asking, saying the demo showed the handling of a self-contained model. What about referencing, naming, and namespaces?
Shall I start? You're right. If model we saw is a self-contained model, but the specification allows for random, what we call model chunks. So any subtree can be handled. References, we base references on IDs. And if you have a node, it could be that you have a node, you have all the IDs of the children, but you might not have the children locally. So you might not show them, but if you need them, you can get them from the repository. So you can partially load models, do with it what you want as far as they are available. References is by ID, but if you look into our meta model that we're in, then references are actually have two parts. They have an ID, something to which it points, and we also have something we call resolve info, and in there you can put a name. So if you throw away the referred element, you still have an indication of what something is supposed to refer to. Nico's trying to show that. So here it says it refers something with the ID IO LionWeb props value, which is a node which is somewhere else in this file, and the resolve info uses the name of the node. Namespaces is interesting because a namespace is very language specific. What do you call a namespace for a specific language? And that's something that we don't define in LionWeb. So how you resolve things exactly in your language, that is something you have to define as part of your language definition. Once you resolve them, we can store them and do things with it.
There is one concept which is related to this. We talked already about these derived models, right? And in our fantasy, also the scoping is, we say everything is a model, right? Also the scoping in the end is a model. So the idea is in this case a derived model. So the idea is that you have some processor who by some magic way calculates the scopes, and that probably includes namespace resolution and things like that, or limitation, and then gives the result again as a derived model. So everything is a model, also the scopes are a model, and this is how it ties in with the rest of LionWeb.
Thanks. Thanks for your answer. We had a couple of people pointing out that the link, the Slack link, looked to be expired. Federico has shared a new one, but just a heads up that if you run the presentation again somewhere else, maybe you may want to update the link. Then we have another question by Martin Steen. Could you say something about the amount of effort required to integrate an existing workbench with LionWeb?
Yeah, we can. You want to take this one?
Yeah, I can. I get it obviously depends on several things. I think the main thing is how close would your meta model be to the LionWeb one. We've briefly seen it, and it is pretty similar to most of the other heavily used meta models I've seen. So I guess there's a good chance that it's not so hard. In the details, you sometimes get a bit. Of course, it always gets a bit hard. The thing I would be really interested in seeing it seeing it to an experiment to integrate it with the heavily name-based system, right? The what's called N-term systems. I never was at a decent university, so like Protego and Rascal. I think it could work, and I had some discussions about this, which at least did not entirely discourage me, but that would be really interesting.
Can I add something to this? First of all, Throne is actually name-based, and it is integrated, so it is possible. It's at least one example. And the other thing is, if you talk about integration, if it's just about exchanging models using the LionWeb JSON format, our experience is that that's actually not so hard. If you talk about integration on the level of having a LionWeb repository and doing collaborative modeling and sending and receiving deltas, that is, of course, going to be much more work. And it depends very much on whether your tool is able to deal with it at all. So the basic integration of just interchanging complete models is, I think, not so hard, but the deeper the integration gets, the more work it gets.
Thanks. So we have another follow-up question by Jürgen. And he's asking, I have seen a parent attribute. Do you have vision about model inheritance, versioning, evolution, and composition?
If it says parent, it actually means container, the owning node. It's not parent in the sense of inheritance here. Just to clarify, it can be read in different ways. We have a vision or thought about how to compose languages, because it depends on when you talk about language or model composition. If you want to compose languages, basically you can use multiple language in, I think, more or less any way you like in LionWeb context. Version and evolution, we have thought about it, but we haven't gone very deep in there. I don't think we've done anything to stop actually defining that and getting some kind of evaluation versioning system running, but we haven't defined that yet at all. I'm not sure what you mean with model inheritance.
Maybe I can add two things. So the version you see, we for anytime we refer to a concept, so that's the classifier thing, it's a triple, right? It's the language version, and the concept which is part of the language. So we thought about language evolution. There's nothing in place yet, but the infrastructure is there, so you can have this version here. And I don't know what model inheritance is. So if you think about the meta model, the meta model has all, as I said, it's a very standard meta model. You see here, interface can extend interfaces, concept can extend concept can implement an interface. So the classifiers, it's all the standard thing you have. And languages can refer to other languages, of course. So concept from language A can extend language from concept B. We don't, besides any kind in a generic dependency, language A depends on language B, we don't have any more specific relations. And versioning in the sense of something like Git is definitely on our roadmap to have some ideas how to support this in the repository, but it's not something that will come very soon because it's a pretty tough topic.
Okay, thanks. We have another question by Mike Vogel. Is MPS used as the server with multiple users editing the same model instance, or is something like ModelX needed to build a solution?
I can take that. So yes, in the demo, we used MPS as a server, and then of course we get MPS, so no multi-user. If several clients would access it, it's as if each of them sits in front of this same MPS type. So any kind of concurrency is as you might happen there. The repository that Jot is currently implementing is also, as far as I know at the moment, has no multi-user capabilities. But ModelX is currently also working on the implementation of the bulk protocol. And then, yes, you of course would get the ModelX features. Again, this like cooperative repository access is also something we definitely have on our roadmap for some time in the future. Again, not one of the easy topics.
Okay. Let's wait some more time if to see if someone else from the audience has any other questions. In the meantime, I have a question for you. You showed examples in MPS, Eclipse, and Kotlin that are all solutions that are JVM based, and also an example with Freon, which runs on the web. So I understand that there are already bindings or implementations for JavaScript and the JVM world. So are there other implementations for other languages or environments available right now, or what's the roadmap for that?
There is at least there is at least one other implementation. In C#, we actually have a paying customer already uses LionWeb internally, and they internally develop a version in C#. It's definitely the idea to open source this. Yeah, it's a big company, so as you might imagine, open sourcing stuff takes some time. But yeah, so these are the ones. And we actually in Slack, there were people who asked to implement it, I think in Haskell, and it was one other question. I haven't seen any of that, but yeah, but you know.
Great, thank you. If there are no other questions, I will ask yet another myself, and then we can move on with the next talk. So I was wondering, you showed a demo which was actually multiple demos, all in one, and I wonder how much automation is there. I mean, you had these Gradle tasks, but they acting like a bit of a black box, but how much of what you showed was generated using some tools, or how much you did write by hand, sorry.
Yeah, so there is a huge thanks to one of my colleagues, Atanas. He taught Gradle and the different Gradle plugins to do all of this. So what you saw is all the, of course, there is some the actual generators. So like these classes, right? They are written by hand, and the code to call the converters is also written by hand. But these are now I will not try to find one of them now. But this is the typical glue code, right? It's and the infrastructure stuff that it is really hard to get it together, but we've done that. So it's this usual fight you have with build systems and dependencies and class loading, and okay, in this case it's all JVM, so we don't have to find NPM, but yeah, that's what you need to do when you do it in TypeScript. But so all the actual classes which represent properties and int values in all the different systems, all this infrastructure is completely generated. So that's hopefully you've seen, or you could at least imagine how it's done in all the during the demo.
Yeah, if I speak for the Strum implementation, the whole language definition, everything around that of saving and retrieving languages, that's all completely automated. The only thing that is handwritten is the actual editor, because you have to define the syntax for that, which is not in the MetaMeta model. And this specific editor is actually, I think it's 20 lines of editor codes to do that, but you have to do it by hand. So every tool has its own specific function, which you have to do the way the tool does it. But all the communication and the language and the model handling is, well, more or less completely automated.
Okay, thank you very much. I see there are no more questions, so we can move on to the next talk.